Hi there, my name is Frank and this is my lab, and I'd like to introduce you to a digital pedal, guitar pedal that I've been working on, and this is part one of a continuing series of videos. This would be the introduction on a digital guitar pedal that I built, and in today's video I'd like to just go through how the pedal works, demonstrate some of the effects, and go through the user's interface. So this is the pedal, and this is the box itself, and this is a 1590 D size box. It's like one of the biggest aluminum boxes, enclosures that you could get, and these are the cards. Now right now I don't have the cards installed inside the box, although they do fit. It's a tight squeeze, and every time I put it in there I get a short or something happens. There's a lot of wiring involved. So for now, I'm just going to keep it outside the box. Eventually, I like to put it in there. But if something breaks, it's much easier to keep it outside the box. But it does fit in the box, although I could probably use a slightly bigger box, but I can't seem to find one any bigger than the 1590D size box. So basically, for the electronic components, there's three elements to it. So there's a Nucleo board. There's a card, a custom PCB card that I made. And the main chip on here is a audio codec. It's a 32-bit stereo, 2-channel in, 2-channel out audio codec. And this part over here, you can see the little chip. It's in a QFN 32 package. I soldered it to a board so to make it easier to work on. And that part number is it's a Texas Instruments. It's a TLV 320 AIC 3254 chip, and that's what it is. And I have a couple op amps and some op amps on it. So this part of it is a Nucleo board, and it's made by STM Microelectronics. So it uses the STM32H7 series. You can see the big chip there, microcontroller. So this is one of the fastest ones you could get. I really like these. These are you could do real good deterministic frame times. So this system I have it currently running at 20,000 hertz update rate. So that's 20,000 frames a second, which I found is good enough for audio. I did have it running at 40,000 hertz, but in order to get all the instructions of the algorithms I needed to slow it down a little bit to 20,000 hertz. So this board is a Nucleo H7 it's a H7 232 GZ, I believe. Okay, so there's a whole bunch of Nucleo boards you could get out there. This is one of the fastest ones. You could use, if you have one of these, that's great. They cost maybe about $30, and you could get them from DigiKey or from STM Microelectronics. And they're relatively cheap, and the nice thing about it is the software now is all free. I'm using Cube IDE. Previously I used IAR Systems, but that was very pricey. I'm just a hobbyist. I don't do this as a business or anything. It's just a hobby for me, so it's fun. So the third element is a power supply. So I have a 3.2 volt, a 1.6 volt, and a plus or minus 15 volt power supply for the op amps and for the audio. I try to keep the power separate from the power in the Nucleo board to try to keep the digital noise out. So this Nucleo board is powered off 5 volts from a USB, so I could either power it using 5 volt USB power, or if I need to program it, I take this out and I put in a USB that's connected to my computer so I can program it. I use a software package from STM Microelectronics. It's called STM Cube IDE, and that's the integrated development environment that has a software. It's all written in C. So the nice thing about a digital pedal is that it gives you a lot of flexibility. It's all up to your imagination on effects that you could do. And one thing I like to do in the series is go through how to develop some of the algorithms for this. So that would be interesting. So I'd like to talk a little bit about the user's interface to the box. So the box has 6 potentiometers on it that are assignable, and you could put in a lot of effects. There's a lot of memory in here. I believe it has 1 megabyte of RAM, or even more. They have ones now that I think go up to 2 megabytes, but this is you could buy these Nucleo boards. There's all different ones, and I happen to be using the this particular one right here. So anyway, the user interface is I have 6 pots, and these allow me to control volume or parameters real time. And I have a selector switch, and this is a 1's up and down switch. So what this switch does, it allows me to select the different effects. So right now I think I have 42 or 43 effects. So by pushing this up, it goes to the next effect. And then I have a 10's up and down, and the 10's up and down, it skips 10 effects. So I could go up 10 or down 10. So it gets me to where I need to go faster. So I have 2 switches here. One's called switch 1, switch 2, switch 3, switch 4. And these switches allow me to select a discrete kind of parameter, unlike the pots where I could vary something, an analog type signal. This allows me to switch discretely within that effect to make quick changes. So it has a display here. I believe it's a 1620 LCD I2C display here that I added. And this is the stomp box switch. So it's true bypass. I don't know, you can see there's a little LED here, so when the effect is on, the LED lights. And I'll try to go around here on this side. If you could see, I have two inputs. These are the inputs. There's a left and a right input. So that's the guitar input. So by default, the left one is used, and the left one is the one that goes through the true bypass, and the right one is an extra input that I can mix signals with. So I could do stereotype effects or effects that depend on more than one channel. And let's see, on the other side here, let's try to move it over to the other side, if you can see that. So I have the outputs. So these are the left and right output. And I also have the USB power input. So this is the 5-volt power that's feeding this box, that feeds the main power for this whole system. So next what I'm going to do is plug this in and try to show you some of the effects, how it works, give you an idea of something that you might want to do. You might want to build a digital pedal. There's a lot of nice analog ones out there, and digital kind of opens up a whole new thing to you. So it gives you a lot of flexibility. So here's my guitar. I have it hooked up to the pedal. So I'm using 1950s style Stratocaster, and this is here's the pedal here. So you can see this is the guitar output, and it's going to the input on the pedal. And I also have an amplifier here. It's a Fender Blues Junior amp over here. So you could see the input to the pedal is tied to the output of the input of the amp is tied to the output of the pedal. So that's just the basic setup. I don't have any other effects. You can see the amp here, the Fender Blues Junior. It's got one 12-inch speaker, and this is the pedal, the digital pedal. Now, one thing I would say, I wouldn't suggest this to be like a production type of thing. It's more of a research and development type of thing. So this thing isn't really ready for production. I'm not planning to produce it as, I don't have a business. I'm just doing this more as a hobby. So we'll power it up soon and go through some of the effects. So I have this mounted while just laying on some styrofoam I got from when you get medicines in the mail that are refrigerated. This is like the lid, so that is very insulated, so it's very handy for putting your electronics on, not having to worry about shorting out. So I'm going to go turn on the power here. So the power's on, and I'm not sure if you can see the display on there or not, but I'll try to zoom in a little bit to the display. So that tone you hear is the default effect, and as all it is this 440 hertz sine wave, and it tells me that it's on. So I don't know if you could see the display there, but it's lit, and I'm going to try to zoom in a little bit on here and try to go through some of the effects. So the first effect, I'm just going to go down one. So the first effect is just a delay. It's just a delay, a 1 second delay. So I'm going to hit a note here so you can hear the delay. So I hit the A string on the guitar, and so you can hear the delay. So I'm going to hit it now, and that's the delayed signal. So I'm going to get a guitar pick here and go through some of these effects just to demonstrate this digital pedal. And what I like to do is go through how to build it, how it's designed, how to set up the software, how to do some of the algorithms. So this is it's called a circular buffer. So I'm going to put the volume up on this amp a little bit. So that's just a basic delay. It doesn't have any adjustments or anything. So I'm going to move on to the next effect, which is that 440 hertz sine wave. It's just a test signal, so I know I'm connected. So this is effect 2. So what this is it's a bandpass filter, a second order bandpass filter, and it sweeps. Might be something like a phase shifter. But I hope in future videos to be able to go through the algorithm. So the next effect, so this is what you might call a flange. So that's a typical flange. So we'll go to the next effect, up to effect 4. So this is a slightly different type of flange. The previous flange used a triangle wave to sweep, and this is a sine wave flange. So you could do all kinds of things. I haven't thought of all the ideas that I'm going to do with this. So let's go to the next effect. So this is a cheap reverb. So you can kind of hear the reverb in there. But it's a cheap reverb. I only used a few delays. Reverbs have like thousands of delays in it, but I only used maybe 10 in this one. So it's a cheap reverb. So this is an echo effect. So I programmed that in. So this is a reverb that has some feedback in it. So it's almost like an unstable reverb. So if you're interested in doing digital signal processing or doing guitar pedal effects, this is a good hobby to have. So let's see what the next effect is. Okay, this is a clipper, so it's more of a distortion type. So I don't believe you could do good distortion effects on a digital pedal. You could get some distortion, but you can do some things distortion-wise on a digital pedal that you can't do on an analog pedal. So we'll go through some of them soon. So that's a clipper, and this is just a straight feed through. So I use that for testing, just go from A to D, back to D to A. Nothing interesting about that effect. Okay, this is a sine modulation. So what it is, the signal's multiplied by, I believe it was a 100 hertz sine wave. So it's neat doing these type of modulation effects. Okay, the next effect is just a fixed delay. I believe I set that delay to half a second. So this is a rate limit, which is another type of distortion. Instead of clipping the signal, you put a limit on the rate of change of the signal. I guess they call it the slew rate. Okay, so rate limit, okay. So this is a variable delay. So I added a 1 here, it's effect 13, but the 1 means that the first pot does something, so this first pot could vary the delay. So that's a long delay. But I set it so I could shorten the delay. I believe that's 0 delay. So that's a very short delay. Okay, so this is a bandpass filter, and it's a sweeping one. So I believe the first pod effect, the first variation is the frequency. So I can vary the frequency. So that's a very slow frequency to a very high frequency. And I can also vary the depth of the filter. So that's a very deep filter. So I'll take some of the depth out. Maybe lower the frequency a little bit. So we'll go to the next effect. Okay, this is a double bandpass sweeping filter. So it's a stronger type of filter. So the next effect here, okay, this is a fourth order bandpass with a triangle sweep. So we'll set those pots back. Okay, effect 17. It's a flange with some adjustments. Okay, this is another flange type of effect. Yeah, so you could come up with some neat effects. Okay, so this is just a 1 second delay. But I put the capability in where I could vary, like it has a wet and dry volume adjustment. So this is another bandpass filter. But you can vary the sweeps, the start and stop frequencies. That's the depth, the zeta of the filter. This is the same effect with just a low pass filter at the end of it. So this is a high pass filter. Up it went unstable. Let me reset it. So you could send the filters unstable. So let me get back to that effect. And we'll try that again. So you could do some things on this pedal you can't do on others. Like send your filters unstable. There it goes again. So this is just a low pass filter. Nothing interesting there. Okay, now we're going to get into the decimate and interpolate type effects. This is a decimate, but you can adjust it. It's skipping samples. So this is like a reverse decimate. So it like plays everything backwards. So this is an interpolation. be this one does a decimate and interpolate. So that's just another straight feed through. So I could test the A to D's and D to A's. So this uses an I2S interface. So this is two separate delays. Sine modulation, okay. So this is kind of like maybe like a tremolo type effect. There's the frequency. These are more attack and decay type effects. This is a squared one. This is a cubic one. I'm going to do a reset here. So this one's a sweep modulator. Anyway, that's my catalog of effects that I have in here, and I'm working on other ones, but just wanted to demonstrate this and show it, and hopefully maybe other people might be interested in building something like this. So bye now.